Hi, everyone, and it's great to be here at DevSecOn 24. My name is Barak Schoster. I'm a software architect at Bridgecrew by Palo Alto Networks. Today, we'll talk about graph theory and PolicyAsCode. The talk has three super easy parts. The first one, we'll talk about what is PolicyAsCode. Then we'll go to a crash course on graph theory. We'll try to simplify it so nobody will panic about combinatorics or mathematics. And we'll go a step deep into Chekhov's internals and see how graph queries are working for it. So I thought for a while on this talk, and since it has policy as code in the title, I thought that it would be matching to discuss a little bit about the history of policy as code the way I have captured it. So it's very biased and it's on a non-linear timeline. But since I've been working on YAML stuff and trying to make YAML stuff be exciting for the past few years, I thought to give it a shot. So for me, if I'm trying to tell the story of the evolution of policy as code, it's really a set of stage phases. I met them first as a software engineer in a big enterprise, and then I encountered policies again in startups and other big enterprises that I had a chance to work in. At the beginning, everything was very manual. Businesses, committees, and regulations came together to create a set of best practices to secure data centers or cloud environments and the applications that run on top of them. After a while, enterprises have started to work with auditors to enable expansion of business and make sure that the right methodology and controls are in place. Best practices and reports like ISO or SOC 2 Type 2 or PCI, if you are a company that works in the fintech area, have started to take place as industry standards. Auditors have started to ask things like, where do you store your data? Who has access to the production environment, and what is the process to gain that access? Are you following secure development principles like OWASP Top 10? And it was good. We started to have a discussion on what should the market look like? What should be the best practices for security? And that was the job of the auditor to help us make sure that we have all of those best practices in place. And it was the job of the director of engineering or CISO or CTO or CIO to answer all of those different questions of, is my environment following a set of best practices? And in the beginning, it was very manual. I really did not envy the director of engineering that should have answered all of those policies. It was a giant piece of work, spreadsheets over spreadsheets of policies. The ment was good. We wanted to be more secure and be compliant with best practices and to enable our business to grow to other dimensions. But it was very tedious and boring tasks. The good thing about it is that smart people got opinionated and have evolved those policy papers into online documents in things like Confluence. Information security practitioners have wanted to create the policies that are best matching their organization risks. Started to do threat modeling, and they wanted to collaborate with other teams or within the team and have the ability to integrate that to a ticketing system like Jira. So they've created an editable, shareable, collaborative document in Confluence or internal wiki with the policies that are relevant for your org or application by the threat model that you have in your org. And it was integrated to Jira natively, so you can convert a policy into a set of tasks that are managed by the IT team or SRE or DevOps. Soon people realized that maintaining such a set of policies can be hard, disruptive, and very manual task. So you get more good people on that topic, more smart people that will try to automate that process and have continuous auditing on those policies on top of the data centers and cloud environments that you have. So those smart people have started to create scripts. We could start seeing basic automations for scanning policies on top of the running environments. Those scripts were running on hourly or daily basis, and they were making sure that things like VMs, databases, serverless functions, and their networking configuration are compliant with the best practices. And if not, automatically create a Jira ticket and assign it to the matching owner within the engineering team. So this helped the cloud security team or the information security team to scale and always audit, always on all of the different running servers. But it have inflated the SRE's team's backlog with endless tasks on top of resources that were already deployed and they were already out there in the AWS, GCP, or Azure account. And when SRE teams have transitioned from provisioning resources manually through the different consoles of the cloud provider to infrastructure as code, pushing different versions of microservices multiple times a day to production, the solution of monitoring the cloud environment after resources were already provisioned took too many times, a lot of effort, and had too much friction. So you take another group of smart people and you ask them to create a linter. The different manifests languages, the different configuration as code languages like Terraform, CloudFormation, ARM template, serverless, and Kubernetes, and even Helm charts and Kustomize, and before that, Ansible, Puppet, and Chef, have introduced us the capability to actually unit test before resources are provisioned and as part of the development lifecycle, those same policies, making sure that a resource is encrypted, that the right IAM, identity and access management policies are in place before anything is getting provisioned. So some PolicyAsCode engines came out to the world. Two popular ones is OPA, called OPA, by the CNCF, the Cloud Native Foundation, and Checkov by Bridgecrew. So hi, I'm Barak. I'm the maintainer of Checkov, or one of them. And we're going to focus on that and some of the things that we've learned along the way. So the idea of PolicyAsCode is that you write in high level in code in Python or YAML or Rego in text files, the policies that you have. And you can use those policies and store them within a version control system. Use automated testing of them, automated deployment, peer review them, etc. So we took the different policies as code and we will see one example, and it has some other advantages. You can also integrate policies as code engines into your CI/CD pipeline, and it will help you to inspect the different manifests before provisioning the resources into the cloud, or even run them as a pre-commit hook or an IDE plugin to review automatically a set of best practices and make sure that your code is compliant. That way, we have distributed a lot of the manual tasks that were previously been done by an auditor and then reviewed on running environment to something that is really part of the development lifecycle. The reason that we've done that is that what we like the most as engineers is when we have a task to get done with it and to move to the next one. It's really bugging to return again and again to the same tasks and fixing stuff. You just want to move to the next interesting topic that you need to develop. So Checkov was built to inspect and do static analysis of infrastructure as code on manifests like Terraform, CloudFormation, serverless, Kubernetes, and others. It has a pretty good coverage and more than 100 different open source contributors. So let's do a quick install of Checkov. So what we'll do now, we'll pip install Checkov. I've already done it on my host. And I have a Terraform code for an S3 bucket. I'm going to run this Checkov command that will verify if my S3 bucket have backup and recovery in place, meaning having versioning in place. And I see that it doesn't. How does this policy look like? It has a section of metadata, which includes the name of this policy. Ensure that S3 buckets, which is an object storage, have versioning, which is a backup and recovery configuration for it. I gave it an identifier. I told Checkov what resource to inspect in code. And I've also told Checkov what attribute to inspect. I told Checkov that versioning should always be enabled for my S3 buckets. So from now forward, on every time that I'll try to add or modify or scan an S3 bucket on top of defined in code, in Terraform code in my case, I'll understand that the lines that are missing are actually versioning being enabled. If I'll add that, I can pass the test of Checkov. So Checkov has about 800 different policies that were contributed by different companies from the community, and you can enjoy those inspection of your code automatically. The thing is that on Checkov 1.0, we were only able to do attribute inspections. What does that mean? It means that we know to go on top of a configuration and ask, does an attribute equals a value, or set of attributes equals a value? But the thing is, environments are more complex than that. So the story of evolution is really about the productivity of authoring the compliance of our cloud environment, or the best practices that we have in our cloud environment, or internal policies that we have on our cloud environment. But it's all about productivity of those manual tasks. We increase the level of automation of policy auditing in each step of the way, starting with the basic policies dictated by the market best practices, and going forward to custom ones that we have decided that are relevant to our own organization based on a threat model that we've done on our data center, AWS account, or application. And from there, we're making sure that a linter is assisting the development teams to handle misconfigs faster and in an easier way. But as I mentioned, it gets more complex than that. Modern cloud infrastructures are having a lot of microservices. Resources depends in each other. You will often see a compute resource that is attached to a networking configuration, and that's attached to an RDS, a database, and that's attached to a storage mount, and that's attached to an IAM policy. So all of those resources cannot work as a whole web application independently and give our customers a service. We need everything to be orchestrated correctly and be configured correctly in order to have a working cloud environment. So infrastructure as code projects such as Terraform or CloudFormation have built a data model called directed acyclic graphs to model relationship between resources. So operators of cloud environments can safely manage the change of infrastructure resources and their dependencies on bare metal, IaaS, PaaS, and SaaS. Let's take a look on a sample architecture. Here's a simple web application. That's crazy. It has a lot of moving parts. We can see here DNS helping us to match IP address to a beautified name in the web browser, a CDN for static content that is stored on object storage on S3. This is in AWS, this example, serving us JavaScript files, CSS files, etc. An application load balancer, a set of compute instances with auto-scaling group, a queue, and a data pipeline that is managed on EC2 instances with access to RDS, the RDS backup, which is the database backup, and also those same compute instances responsible for data pipeline have a mounted storage of EFS. So that's a lot of moving parts. And we have a lot of policies that the market is telling us, hey, those are really the best practices that you should follow. So this specific diagram, or similar to it, was actually presented in HashiConf on 2016 by Paul Hinze. So a lot of this talk is inspired by his topic on graph theory. If we want to apply a policy on this infrastructure, we would probably ask questions like, is the file system encrypted? Or is the security group that is attached to all of the different instances has port 000 open to the world? Meaning, is my instances public? But the thing is, I don't really like to ask a lot of individual questions on EFS and security groups. The thing is that I want to understand from threat model perspective is there an actor that could access my EC2 instances, and does those EC2 instances has unencrypted volume so that if data is leaked out, is it leaked in an unencrypted manner? So the actual query that I would like to do is a traversing query. I would like to ask, do I have a path from the internet into an instance through a security group and into an unencrypted bucket? So I want a query that is aware of the dependencies of my cloud environment. So we need a strategy to ask dependency-aware policies. And this is where the second part of the talk goes. I know that graph theory has discrete mathematics, combinatorics, and some complex math stuff, but we'll really simple it down in 2 minutes. Let's give it a try. This is a node. A node represents a code block. A Terraform code block can be a provisioned set of instances in the cloud environment, or it can be a configuration that is attached to those resources. And this is an edge. This is another edge. The edges represent a relationship between different nodes, in our case, in the cloud. A graph would be a set of nodes and edges that are attached to each other. So a directed graph would just mean this is the direction of the relationship between those different nodes. So a directed edge will give us a directed graph. And a directed acyclic graphs just means that I don't have circles between 3 nodes, for example. The next operation that we can do on top of a graph is actually a walk. Let's take a look on how our DAC walk. A DAC is our scanner, and it can walk through different edges by the direction of the different, walk through the different nodes by the direction of the different edges. It can actually perform actions like look for a connection between different nodes or scan their attributes. So it will traverse over the different nodes by a specific direction. It sounds reasonable, and we can actually apply it on an architecture like the following one, where each and every resource defined in this diagram is actually a node. And all of those dependencies are actually the directed edges between the different nodes. And this is how it will look in code. Over here, I have another example. I have an EMR cluster, a Spark cluster for the production data engineering team. This cluster is attached to a security group from development environment. And this security group, which is a firewall configuration, is attached to a variable that defines what are the allowed IP addresses or CIDR blocks to have access to that EMR cluster, networking access. And I actually have an even slightly larger code that defines 2 EMR clusters. We have our production data engineering one, and we have another one called data science. Each one of them is attached to a different security group, and one of them is attached to a variable. So this is my Terraform graph. These are the different dependencies that I have defined in code on top of my cloud resources. And the question that I would like to ask, or the policy that I would like to have, is to ensure that Amazon EMR clusters security groups are not open to the world, to the public internet. Or to simplify stuff, make sure I don't have public sensitive stuff out there. So I'll create a graph query. A graph query or a graph policy is something that we've introduced in Checkov. It's open source too, under version 2. And we can ask complex queries on top of relationship between cloud and cloud resources, making it more matching to our threat modeling question that are asking not only if a resource is compliant, but is there a real risk? So over here, I've defined this policy of EMR that are not public to the world. I've defined a category, which is networking, and given it an ID on the policy metadata. The next part would be to define a connection block. So a connection block would be look for a connection that exists between 2 different resource types, EMR cluster and security group. If you have found one, move on to the next step, which is inspecting an attribute. An attribute block would inspect an attribute of one of the resources within the connection, and will check if the security group has on each CIDR block any value that equals the entire internet, 000. And filter is actually something that will make things faster for us. It will tell our traversing logic to focus on or to start traversing from EMR clusters. So if we have a huge graph out there of hundreds or thousands or tens of thousands of resources in the cloud, we can focus the query to start on the most matching place and traverse from there. And the last is I want to have an end condition between of those different blocks of query. So how it would look like, we'll go from the EMR cluster into the relevant security group, and from there to the relevant CIDR block, and then verify if we have 00 defined. If we have, we're failing the policy. We have a public EMR cluster. So on the graph, I'll run a depth first search. It's a DFS algorithm that is used to traverse graphs or trees. The algorithm starts at the root node. It can select an arbitrary one, or it can be defined by a filter. And it explores the possible path on top of each and every branch to answer our query. So we'll go to this branch, the provider of AWS. From there, we'll go to the EMR cluster of data engineering. We'll go through the security group that is attached to it, and we've identified that we have a bad CIDR block, a public networking interface, public networking security group defined for the ingress rule. And now we'll scan if there are any other instances of public EMR blocks. We'll go to the second cluster, and we have identified that the second security group is actually in a good state. Let's take a look on the demo. I have another Terraform code, 2 EMR clusters defined, one for data engineering, another one for data science, with 2 different security groups, one for dev, which is open to the internet, and one for prod, which is actually segregated. I run Checkov with a specific check ID that I've just defined, which is CKV AWS 7, scanning the local directory of Terraform, and I can see that I have 2 different clusters. One is fine and the other is not. So what just happened? Checkov have read the infrastructure as code that I have defined in my local directory or Git directory. It has created a directed acyclic graph that represents the same graph that would have happened after deployment in production environment. And on top of that graph, on top of that data model, it have executed 2 types of policies: attribute-based policies, like do I have versioning enabled for S3, and graph-related policies, asking about the relationship of 2 or more resources and their attributes, enabling us to ask more difficult questions like, do I have any public instances with unencrypted volumes, or public EMR clusters? So I can take Checkov as if I did in locally, and I can actually put it as CI step. It can run as a GitHub action, a container, or a GitLab runner. Any way to run a utility, a container utility within a CI. So on every pull request to GitHub, Checkov can actually run a set of security tests of policies as code, inspect our infrastructure as code, and if everything looks fine, we can trigger a deployment to our destination account or project between the cloud environments. And if we integrate that as a GitHub action, we actually have a failed state of successful or failed execution. So what other stuff does the graph abstraction enables? The fact is that the community is actually asking those kind of graph queries all the time, each other. Information security teams, networking teams, DevOps teams are asking those stuff to help prioritize what's the actual risk I have in my cloud infrastructure code versus what's just a compliance best practice. So example questions would be ensuring that we have volumes attached to EC2s and they are encrypted, having S3 buckets attached to public block access, RDS clusters that have backup plan defined, and even KMS keys, making sure that they do not have the ability to be read by anonymous user or are not publicly accessible. So those are different use cases that you can actually define in a graph policy because they cannot be defined on a single block, and they should be inspected by correlation of different code blocks that in some cases are scattered across multiple files or repositories, but in Terraform, they are dependent in one another. So the graph is actually giving us a solid data model and room to evolve. The community is asking for graph queries for years each other. So it's actually an opportunity for the community to contribute more and more policies into Checkov as a shared hub of best practices. The graph query is a composable query language, so you can add more and more condition to it and make it more robust or inspect the right things that you care about. It's a composable data model, so you can actually ask queries in the future like, do I have public unencrypted container orchestrator like EKS or Kubernetes, and does it have vulnerable images? So it's also publicly accessible and exploitable. It can be integrated to part of the software development lifecycle like CI systems. So it's really an opportunity to correlate all of the important stuff in information security with the CI pipeline. And another example to the opportunity that the graph may give us is we can actually ask questions that correlates the code state, meaning is our code defined as secure infrastructure? And is it attached to a running state of cloud environment that is also secured by the same manners? So graph is only the beginning, and we are only in the beginning of the implementation of it within Checkov, but it really excites me because it really has a lot of places to grow and a lot of application we can build on top. So I would be very excited to see you all contributing code to this open source project. And you're more than invited to give it a try or ask question on Chekhov's Slack channel or even ping me over email. Thank you again, DevSecOn. I'll be here in the chat if you have any questions, or you can reach out right after. It was a pleasure.